Okay, so in the previous lecture, we have started with the regression analysis and we have solved some problems based on finding the lines of regression. Okay, so let us have some more problems based on the lines of regression. So here we'll see some more problems. Now, here, before going to the problems, we'll have to understand some remarks. Okay, so these are the observations that we need to understand. Okay, so first thing we need to understand is the signs of byx and bxy are always same. Okay, so what we know is then we have what we'll be having here. We have the formula of byx. So it is r sigma y upon sigma x, and we have bxy is equal to r sigma x upon sigma y. Okay. So if we multiply these two byx and bxy, then then we get what you will get is r square is equal to byx into bxy. So this sigma y will get cancelled with this sigma y, this sigma x will get cancelled with this sigma x. So you will have r square on one side and then you will be having here byx into bxy. And so I can write as r is equal to square root of bxy into byx. Okay. So moreover, we know the value of r is in -1 and 1 range. Okay. So what we can say is since the value of r is between -1 and 1, hence we have what we can have is r square is equal to bxy into byx is less than or equal to 1. So the square of this will be also 1. The square of this will be also 1. So overall square will be less than 1. Okay, and if we know the product of these two is going to be a positive quantity. So when this product of these two will be a positive quantity, if both will have the same sign that we have written in the first remark. So see the first remark, the signs of byx and bxy are always same. So either this both will be positive or this both will be negative. Okay. Now the sign of this bxy and byx will decide the sign of r. Okay. Why it will so? Because see, byx is r times this quantity, but this quantity is always positive. So whatever the sign of this term will have will be the sign of r, and hence we can say the sign of okay, the signs of r, bxy, and byx are always same. Okay, because we know in the first remark that the sign of bxy and byx is same, but r is a square root of this, so square root may be positive, may be negative. But we know these two terms are always positive. Okay, and hence the sign of this term will be the sign of this term, which is same as the sign of this term. So that's why the sign of byx r and bxy will be the same. So that's what we have here. So now using this remarks, okay, we have to solve the next problems, okay, or next types of problem. So let us see uh, the problem now. Okay. So we have the given lines of regression. Okay, so you can see this is one line of regression, this is the other line of regression, and also given that sigma x square, and then we have to find out what is x bar, y bar. We have to find out r, and then we have to find out what is sigma y square. Okay, so these are the quantities that we want to find out. Okay, now in the remark I have given you that what is the relation and how we are able to get r, or using these relations we are able to get any one of the sigma x or sigma y. But how to get this byx and bxy? Okay, so that we have seen in the previous case. But here the processed data is given already. Okay, so you have given a nice equation. Yeah, the lines of regression is given. One is the line of regression of x on y. The other is the line of regression of y on x. Okay, and how to identify which is the line of regression of x on y and y on x. So this criteria you need to understand. The product of bxy and byx is less than or equal to 1. So if it is less than or equal to 1, then your identification is correct. If it is going to be more than 1, then you have chosen wrong lines. Okay, or your assumption is going to be wrong. So you need to correct it. Okay, so here now we have to understand what is going to be the line of regression of x on y and y on x. Now we are able to get the r from this formula. We are able to get this using any one of these two formula. Now how to get x bar and y bar? So if you remember the equation of line, the equation of line of regression of y on x or x on y, that contains x bar and y bar. And so if you see those equations, the means actually satisfy the lines of regression. Okay, so means are actually the roots of or the solution of these two simultaneous equations. So if I solve these two simultaneous equations, the quantity whatever I'll get will be x bar and y bar. Okay, so this is how we have to think of this problem, and then we can solve this problem. Okay, so let us consider one by one. So first I'll try to find out R, then I'll find out this, and then I'll find out this and the last. Okay, so there is no fixed order. You can do it any order, but this is the easiest way, finding R, then sigma y square, and then L bar y bar. Okay, so we go with the solution. Okay, so what I assume is, I assume that this is the line of regression of y on x, and this is the line of regression of x on y. Okay, so there is no fixed rule that how I am going to identify. Okay, so only criteria that we need to understand is this criteria. Okay, if this criteria is satisfied, then my assumption is correct, or then I have to come back and then correct my assumptions. Okay, so this we have to check after finding bxy and byx, and if this is okay, then our assumption is okay. If this is not okay, then we have to come back and then correct it. Okay. Now, without loss of generality, I assume that this is going to be the line of regression of y on x, and this is x on y. Okay, so let us consider this. Let line of regression, line of regression of y on x be. Okay, so I assume that this is going to be 5y is equal to 4x plus 80, or I'll write this as minus 4x plus 5y is equal to 80. Let this equation 1. But how do we express the line of regression? Y in terms of x. So I take this 5 on the other hand side. So I'll have y is equal to, see this, I'll be having 4 by 5 times x and plus 80 by 5. Okay. Now, what we know the line of regression is, see, the line of regression of y on x is y is equal to byx into x plus y bar minus byx into x bar. Okay. So this is the line of regression. If you simplify this, y minus y bar is equal to byx into x minus x bar. Simplify this and you will get this one. Okay. So now once I know this and then I compare this equation with this equation. So what I get is this constant is 80. Okay. This is 4 by 5 and that's what we have. Okay. So this way we are able to get the constant and the coefficient. Okay. And once I get this constant and the coefficient, okay, I am able to write what is the byx. Hence, we have byx is equal to 4 by 5. Okay. So how do we get it? By comparing the equation to the formula of line of regression. So I assume this is equation 2. Yeah. Now, once we have equation 1, equation 2, now we have to find out what is bxy, because we got now byx. Now we have to find out bxy. So from this line of regression, we have to get that, and hence we write, okay, the line of regression of x on y t. Yeah, so what is that? 14x plus 14x is equal to 14x is equal to 3y plus 10. Yeah, so that is the line of regression we have. And hence I write this as 14x minus 3y is equal to 10. So this is going to be the equation 3. So what we can do is we can take this 14 on the other hand side. So we got x is equal to 3 by 14y plus 10 by 14. Okay. And hence we can write, so we have, we'll get is bxy. So similarly what we can have is the line of regression for x on y is x is equal to bxy into y plus x bar minus bxy into y bar. Yeah, so that's what we have. And hence this term, if I compare, so I'll get bxy is equal to 3 by 14. Okay, so we got this. Okay, now we need to check whether our calculations are correct or, okay, so we have this. Now you can see this is going to be 4 by 5 into 3 by 14. So what we get here, see, 4 by 5 into 3 by 14. So you can cancel, this is going to be at the most 6 and this is going to be by 35. So this you can cancel 2 here and then 7 here, and you can have this is going to be 6 and this is going to be 35. So which is less than 1. So if it is less than 1, then our calculations are correct. Okay, if it is not less than 1, then we have to go and correct our assumptions. Okay, so that's why we have to be careful. So here only you can check that whether you are going in a correct direction or not. Now we got the idea that we are going in a correct direction. Okay, so now what is I want to find out first? I want to find out first R, because I know these two coefficient, and once I know these two coefficient, I can find R. Okay, moreover, you can see byx is positive and bxy is also positive. So you can see our first remark. Okay, the signs of byx and bxy are going to be same. So that are same here. This is also positive, this is also positive. And hence, by the second remark, R will be also positive. Okay. So we can write here from equations 2 and 4, we have. So what will be having? R is equal to square root of bxy into byx. So what we got here? This is square root of b by 14 into you have 4 by 5, and hence you got this 6 by 35. So give me this value correct up to the 4 digits. What is the value you got? 0.4140. That's good. Okay. Right. Okay. So you got the value 0.414. Okay. So this is what I'll be having 0.414. And hence I got the value R is equal to 0.414. So you can see out of our three claims or three things to find, we got one of that. Okay. Now I want to consider the sigma y. So I can find out sigma y square. Okay. Now we have any one of the formula you can use from remark 2. So we can write bxy is equal to r sigma x sigma y. And what is given? Sigma x square is equal to 16. So we got sigma x is equal to 4. Remember, always sigma is always positive. Okay. So by definition itself, the variance is always positive, and the positive square root of variance is called standard deviation. So variance is given. So this is going to be the standard deviation, which is always positive. Okay. So it gives actually the spread of the distribution. Yeah, so that's why it is going to be positive always. Now I know this value, I know bxy r. So I want to find out this value sigma y, and hence I can rearrange the terms as sigma y is equal to r into sigma x upon bxy. So what we get here? 0.414 into this is going to be 4 upon what we have. This is 3 by 14. So that's what we have calculated here. Okay. And now simplify this. So we can have sigma y is equal to. So I can write this as 0.414 into 4 into 14 upon 3. So please calculate and give me value what you get for sigma y. 4 digit. If it's possible, then take one more digit. 4 digits after decimal place 80. Okay. So what you got? 7.7280. Okay. So you have here is going to be 7.780. So you got here 7.780. But we are interested in square of this term. Okay, and hence we have to square. Hence we have sigma y square is equal to. What will be the square of this term? 7.7280. What is the square of this term? 59.7219. Okay, so this is going to be 59.7219. So this was the quantity that we needed to find. So we got this also. Now see what I want to find. We have to find x bar and y bar. Okay, so for x bar and y bar, what we do is we write here. Okay, since x bar and y bar satisfy the lines of regression. Okay. Hence, we can get x bar and y bar by solving equations 1 and 3. So we have, what is equation 1 we have given? See here. So equation 1 is minus 4x plus 5y is equal to 80. So this is minus 4x plus 5y is equal to 80. And see what is equation 3. Okay, so equation 3 we have 14x minus 3y is equal to 10. So it is 14x minus 3y is equal to 10. So we can go directly solving both equations. We get, so what you are able to get here, see x bar is equal to and y bar is equal to. So solve this equation and then give me what is the value of x bar and y bar. 5 and 20. Are you getting the same answer? Okay, so x bar is equal to 5 and y bar is equal to 20. So this way we are able to get the solution of this example using this remarks. Okay. Do you have any doubt in these examples? Okay. So that's great. Let's have the another example then. Okay. Fine. We have the another example. So very similar you have. Okay. Now we have to find out again the x bar, y bar, r and sigma y square. Okay. So we go with the solution. So what we have to do is we have to consider one as a line of regression of y on x, the other is x on y. Now you can see. So what we have here, right? The line of regression of y on x b. So I assume this is to be y is equal to 30 minus 6x. So I can write as 6x plus y is equal to 30. So this is equation 1. Why we are expressing this line as this? Because to find x bar y bar, we want to find x bar y bar so that we can use this equation. Okay, and hence here we can directly write y is equal to, you can see here, minus 6x, okay, then plus 30. So what will be byx? So byx is minus 6. From this you can write as, see, 2x is equal to minus y plus 12. Okay, so you can write as x is equal to minus half plus 6. And now you got bxy is equal to minus half. You can see both of these equations. Okay, so both of these byx and bxy are negative. So first comment is satisfied. Consider the product of this. So if I consider bxy into byx is equal to, this is going to be 3. What is the relation of this 3? Whether it is less than 1 or it is greater than 1. What is the condition? You can see. You got bxy into byx is equal to 3, which is greater than 1. Correct. So is this condition favorable to us? Is this okay? No. Okay. So this is not okay because the product cannot be more than 1. Okay. So if I know that the product is going to be more than 1, that means what I did, I have committed a mistake somewhere. The line of regression which I have to consider is not correct. And that's why what we have to do is we have to correct it. Okay. So first, let us correct that and then we will get the correct answer. Okay. So here, whatever the line of regression I am considering, this is not actually the line of regression of y on x. And hence we have to correct this. So what it means? It means that the first line of regression is not the line of regression of y on x. Actually, it is the line of regression of x on y. So this line is x on y, and this is y on x. So what I'll be having is 2x minus y plus 12. Okay. So sorry here. 2x is equal to minus y plus 12. And hence I can write as 2x plus y is equal to 12. This is equation 1. So I can write here this y is equal to, okay, so what you got is y is equal to, y I am taking on the other hand side. So minus 2x plus 12. Okay, and hence what we can have is we have. So since what we know is y is equal to dxy dyx into x plus y bar minus byx into here we'll be having x bar. Okay, so this is the equation of line of regression of y on x, and hence comparing with this we get byx is equal to minus. So we need this value later, and that's why this is going to be equation. Okay, and now this is the line of regression of x on y. Okay, so we can write here. So the line of regression of x on y is, so what is that? Y is equal to 30 minus 6x. So I can write this as 6x plus y is equal to 30. This is equation 3. Okay. And if we compare this, so we can write here, see, this 6x is equal to minus y plus 30. So I can write x is equal to minus 1 by 6y plus 5. Okay. So compare this equation with x is equal to dxy into y plus x bar minus bxy to y bar. Okay. So if you compare this equation with this equation, then what we are able to get is, so we have bxy is equal to minus 1 by 6. Now you can see both this bxy and byx has the same sign, and you can see the product is going to be less than 1. Okay, so this is going to be 4. Okay, so once I have this all 4 equations, then I am able to calculate r, and then we will go to sigma y square, and then we'll calculate x bar and y bar. Okay, so what I can write is from equations 2 and 4, we have, okay, so what we'll get here, see, R is equal to square root of bxy into byx. So square root of this is bxy minus 1 by 6 into minus 2. So that's what you'll be having here. So this is going to be 1 by 3. Okay. Now tell me what is the value you will have. Okay. So this is equal to. So give me the value. What do you get? 0.5773. Okay. So that's good. You got it easily. Great. Okay. So this is 0.5773. Now see the remark. Okay, so when we consider a square root, so if I consider the square root, so what I'll be having square root of 4 is equal to plus or minus 2. Okay, so I have here plus or minus 2. So I have to consider square root of this. So this will be plus or minus 2. But whether it is positive or negative, this sign will be decided by the remark. So what is the remark I have given you? The sign of R bxy byx is the same. So all these quantities will have the same sign. Now you can see bxy and byx are negative. So since bxy and byx are negative, this R has to be negative. So R will be negative here. So it's going to be minus. Okay. So this you need to understand. So we got R is equal to minus 0.5773. Okay. So this way we are able to understand the sign of R. The sign of R depends on the sign of bxy and byx. Okay. Now once we get this R, we are able to find out what is sigma y square. Okay. So what we know is we have again what is sigma x square given. So sigma x square is again 16. Okay, so what we have here, this is we have sigma x square is equal to 16, and hence we have sigma x is equal to 4. So sigmas are by default always positive, so we cannot take the negative here. Okay, so sigma x is going to be positive. Then what we can write is from equation. Okay, either you consider one or either you consider two or four. So you can have or you can use the same formula. Okay, so equation 4 we have what we have is bxy is equal to r times sigma x sigma y. So I can write here as sigma y is equal to r times sigma x upon bxy. Okay, and we know these values. So R is minus 0.5773. Sigma x is 4. What is BXY is? So y is minus 1 by 6. So we have here, this is minus 1 by 6. So we can write here, sigma y is equal to. So this minus will get plus, and you'll be having this is 0.5773 into 4 into 6. It's going to be 1. So that's what you'll be having. So tell me what is the value of sigma y. Once we get the value of sigma y, we need to calculate the value of sigma y square. So we got 13.8552. Good. You got it. Very good. So it is going to be 13.8552. Okay. So it's great. Having this is 8552. So we got here 13.8552. Okay, this is sigma y, and hence we get. So we are interested in sigma y square. So what is the value of sigma y square? You get 191.9665. That's good. Okay, so we got here 191.966. Okay, so that's what 665. Okay, 191.9665. Okay, so we can have going to be 9665. Okay, so this is how we are able to go, obtain the sigma y square. Okay, and now what we have to do is we have to find x bar and y bar. So let us try what is x bar and y bar. So what we have to do is we have to use this equation 1 and equation 3. Okay, so we have to write this. Okay, so what you're having, since x bar and y bar satisfy the lines of regression. So when I say lines, that means it satisfies both the lines. Hence, we get the values of bar and y bar by solving questions 1 and 3. So we have x plus y is equal to 12 and 6x plus y is equal to 30. Okay, so you can see whether we got it correct. So 2xy plus 2x plus y is equal to 12 and 6x plus y is equal to 30. So these are the equations that we have got, and then we have to solve this. So we can write here solving both equations we get. Okay, so what we are able to get is x bar is equal to and y bar is equal to. So I want you to solve these equations and then get the values. Okay, that's great. Okay, so it is 4.51 or 3. Okay, that's good. Okay, so we got here, this is going to be 4.5, and so this is what we wanted to know. So we wanted to calculate the value of x bar, the value of y bar, and we got it here. Okay, so we can see what we wanted to know. We wanted to know this sigma x bar, y bar, and then we wanted to know R, and then we wanted to know about sigma y square, and then we have calculated it. Okay. So now, do you have any doubt in this example? Okay. So there is no doubt. So we'll go for one more example. Okay. Good. So this is the example you have now. See, what is given here? If two lines of two regression equations are, these are the regression equations given. Okay, then we have to find out the means of x and y, correlation coefficient, standard deviation of y if the standard deviation of x is uh, 3. So first we need to understand what this problem is and then what we want to find out. So here mean values of x and y, that means we have to find out x bar and y bar. The correlation coefficient we have to find out r. Then we have to find out standard deviation of y. So we have to find out sigma y when given sigma x is 3. Okay, so this example is the same as the examples that we have solved earlier. Okay, only thing is that this is asked in words. This is given in words. The previous was in symbols. Okay, so we need to understand what are the words and what are the symbols, and so we are able to use the formula to get the solution for this. Okay, so let us obtain the solution of this question. So what we have is, right, as I said, one of this is line of regression of y on x and other is line of regression of x on y. So first what we have to do is let the line of regression of y on x be. Okay, so as I have given you the idea how to get it. So let us consider this. Okay, so what I'll be having is I am able to write this as in terms of y. So y is equal to, I'll be having 4 by 5, okay, times x plus 33 by 5. So I can have p by x is equal to 4 by 5. And this line, so what you can have is x is equal to, so we'll be having 9y minus 107. This will become plus, and here I'll be having by 20 by 20. So I got bxy is equal to 9 by 20. Consider the product of these two. So bxy into byx, it's going to be 4 by 5, 9 by 20, and what do we get here? So you get 9 by 25. So whether it is greater than 1 or less than 1. So what is your conclusion? Greater than 1 or less than 1? Less than 1. So can we accept this? Can we accept this assumption? Yes. So that is what we have to do. Okay. So first we have to do a rough work, and then we have to set our assumptions such that our rest of the calculations will be correct. As in the previous example, I have shown you that if you do not have the correct assumption, you will not get the answer, or you will get the correct wrong calculation. So to get the correct calculations, we must have the correct assumptions, and hence we have tested our assumption that it found to be correct, so we can use it. Okay, and hence let us solve the remaining problem. So what we have to do is, the first is the line of regression of y on x. So I write here this is going to be 4x minus 5y plus 33 is equal to 0. Okay, so is going to be 0. And hence, now I got the idea. So once one line you are able to get the correct, the rest of the calculations will be correct. Okay, and hence I can write this as, 4x minus 5y is equal to minus 30. So this is equation 1. We want in terms of 5. So I'll be having, this is 5y is equal to 4x plus 33. And hence we write y is equal to 4 by 5 x plus 33. So here we need to be careful. Okay. So it is going to be 33 by 5. Okay. And what do you know is, since the line of regression for y is equal to byx into x plus y bar minus byx into x bar. Okay. So comparing this, we are able to get, and hence we have Byx is equal to 4 by 5. Okay, so that's what we got. Byx is equal to 4 by 5. Let this equation. Okay, now the line of regression of x on y is. So what is the line of regression of x on y is 20x minus 9y minus 107. So it is 20x minus 9y minus 107 is equal to 0. So I can write this as 20x minus 9y is equal to 107 is equation 3. So I can write this as 20x is equal to 9y plus 107. Or we can write this as x is equal to 9 by 20y plus 107 by 10. And using this, so what is the line of regression? So you're having x is equal to bxy into y plus x bar minus byx to y bar. Here we have bxy. Be bxy into y bar. Okay, that's what we'll be having. And hence we have. So what we have here, this bxy is equal to 9 by 20. So this equation 4. Okay. So what we want to find out now, we want to find out r x bar y bar and sigma y. Okay. So here we can write here from equations 2 and 4. We have r is equal to square root of bxy into byx. So square root of 9 by 20 into 4 by 5. So this is 9 by 25 and it's going to be 3 by 5 which is 0.6. So you got here r is equal to 0.6. Okay, now I have considered the positive sign because bxy and byx both are positive. Okay, now I want to have the value of sigma y. Okay, so what we have is we have sigma x is equal to 3 and r is equal to 0.6. So what I can write is from equation 4 we have. So p x y is equal to r sigma x upon sigma y, and hence sigma y is equal to r into sigma x upon pxy. So this is 0.6 into going to be 3 and pxy. So it is going to be 9 by 20. So we can write here as going to be sigma y is equal to, so we have 0.6 into 3 into 20 on 9. So calculate this value, or if you have a problem with this, you can write here as this is going to be e by 5. So you can have this is going to be 4. So you got sigma y is equal to 4. Okay, so we got sigma y, and now we want to find the x bar and y bar. Okay, so we have to find out this x bar and y bar. So what we write here, we can write since X bar and Y bar are they satisfy lines of regression. Hence, we can get X bar and Y bar by solving equations 1 and 3. So we have, what is the equation 1 we have simplified? See, it's going to be 4x minus 5y is equal to minus 33. So we have 4x minus 5y is equal to minus 33. And this is what you will be having, 20x minus 9y is equal to 0.07. Okay, so you can check this. Yes. Okay, and once we know the equations, what we can do is solving above equations we get. So what we get here, x bar is equal to and y bar is equal to. So please you calculate and give me the values. Yeah, good, good enough. Okay, so that's great. So it is going to be 13 and 17. So this is 13 and this is 17. So this way we are able to get the solution of this given problem. Okay. So do you have any doubt in this example? Good. Okay, that's great. You don't have any doubt this example. So I hope you are able to solve the similar kind of problems now, and you are able to fit the lines of regression for this. Okay. So great.